Assalamualaikum and a very good morning. Our group has been tasked to do a presentation of the Voyage of low orbit satellite IoT, and the topic we are going to present is the Starlink satellite internet system. Our team consists of 5 members, which is myself, Imran Akib Hide, Afiq Danish bin Nazir Nizab, Aiman Shauki bin Abdul Yazid, Muhammad Zulhilmi Hakim bin Jeffrey, and lastly Raib Musayyab bin Rasni Jari. Goals and objectives on why we choose this topic is to provide fast and reliable internet to remote and undeserved areas worldwide. Second is to reduce delays in internet communication by using network of low Earth orbit satellites, or which is LEO satellites, resulting in quicker response time than traditional satellite systems. And last is to bridge the digital gap by offering internet access to places without land-based infrastructures. Additionally, we aim to provide flexibility with Starlink simple to install satellite dishes, allowing users to choose where they connect to the internet. For the next slide is the example of a block diagram of a satellite, which is a two-way communication, which is going to be explained more in detail by my group members. And the video below it is the visual presentation of a Starlink satellite constellation. There are a total of 4,800 active satellites surrounding the Earth, in which they are strategically placed to create a constellation, allowing our data to travel across the globe.
Alright, you have seen the block diagrams and the visualizations of the Starlink. Now we will go into detail about the process of two-way communications by the Starlink satellite. Firstly, user on the ground utilize Starlink user terminal, commonly known as dish antenna, to send data signals. These terminals are equipped with advanced technology to establish a reliable uplink to the Starlink satellite network. Then, for the Starlink receptions, the signals transmitted from the user terminal are received by the Starlink satellite using their specialized receiving antennas. These antennas are designed to pick up even weak signal from the ground. Once the satellite receives the signals, it converts them to a different frequency bands. This process, known as frequency conversions, helps prevent noise interfering with other signals and ensure a clear communication channels. The Starlink satellite are equipped with onboard processor and routers. This device handle the received signal by encoding, processing, and routing them efficiently within the satellite system. This is known as Starlink payload processing. And then for the satellite-to-satellite communications, the inter-satellite links. Starlink satellite have the capability to communicate with each other using the inter-satellite link. This feature allows data to be transferred directly between satellites, optimizing the overall network by reducing the need for ground station relay and enhance data transfer efficiency across the constellations.
Okay, we continue to the receiver process. So for ground station, after the processing the signal, the satellite transmit them to the ground station. This ground station serves as a crucial hub that connect the satellite network to the terrestrial internet infrastructure. And second is backhaul connection. Ground stations are connected to the internet backbone through the high capacity backhaul link. This connection ensures that the data from the satellite is seamlessly integrated into the global internet network. And third is return signal to user terminal. The data processed and transmitted by the ground station is then sent back up to the Starlink satellite. From there, this is a relay back down to the user terminal, completing the two-way communication link. And fourth is user terminal receiving signal. The user terminal or dish antenna receive the returned signal. This final step allow user to access the internet, providing a seamless and high speed connection. And lastly is a network management. The entire Starlink satellite network is managed by a ground-based network operation center. This center oversees all aspects of satellite operation, including connectivity, performance, and maintenance to ensure the network runs smoothly and efficiently. That's all from me.
For this Starlink satellite system, there are some noise which can be divided into internal and external noise. For internal noise, it has thermal noise, which caused by the random movement of electrons in conductors, directly linked to temperature and present in all electronic components. Second is short noise, which arises from the discrete nature of electric charge carriers, such as electrons. It occurs when current flow across a barrier or through a semiconductor junction, producing random variation in the current. For internal noise, first one is natural noise. It is atmospheric condition such as rain, snow, fog, or atmospheric disturbance. Can introduce noise into the communication link between the user's satellite dish and the satellites. This can attenuate the signal or introduce additional interference. And second one is interference from nearby channels. This is interference from nearby communication systems, including adjacent channel, co-channel, and cross-modulation interference.
Next, for transmitter and receiver. Modulation is a key aspect of the transmitter process for Starlink, as it is essential for efficiently encoding data into radio signals that can be transmitted over long distance with high reliability. So there are several modulation and demodulation that occur in Starlink. So first, the quadruple amplitude modulation, QAM. It combines amplitude and phase modulation to encode data into multiple signal states. It increasing the amount of data that can be transmitted. Next, for the next modulation, orthogonal frequency division multiplexing, OFDM. It splits the data into multiple subcarrier frequency, each modulated with a subset of the data, and it reducing interference and improving the robustness. And for the demodulation in the receiver, so the receiver's antenna capture the incoming signal, and the demodulator extract the digital data by reversing the modulation process. Error correction algorithms then verify and correct any errors that occur during transmission. That's all for us. Thank you.